Hey Unraiders, and welcome back to another Uncast video. And yes, you guessed it, after that opening crawl, this one's all about Unraid 7.1. Now I know you probably didn't need me to tell you that. You saw the title, you saw the thumbnail, you clicked on it. It's not exactly a secret transmission. You know, it feels like version 7.0 only just dropped. And I'll admit my mission to retrieve the plans for this video meant it's dropping a little later than I'd hoped. Transmitting data through Imperial blockades is a tricky business, you know. But the good news is the mission was a success, the plans are in our hands, and that provides a new hope for anyone who may have missed some of the really cool features when 7.1 first dropped. So, let's fire up a server and take a proper look at what's new. Okay, so here we are on my server Serenity. This one I mainly use for VMs. And if you wonder why I've got a TrueNAS VM running here, well, that will become very apparent later on in this video. But for now, the first thing I think we're going to look at is the new feature in Unraid of having built-in Wi-Fi capabilities. So let's go across to Settings, and then go to Network Settings. If we have a wireless network adapter, then we can actually use Wi-Fi on our Unraid server. Now, this can be a real game changer for many different reasons. Well, yes, it's always better to use wired Ethernet whenever possible. But say you move house and you haven't actually got your wired network up and running. Well, we can use Wi-Fi. Even if you just want to move your server from one side of the room to another because you're doing some maintenance on it, we can switch over to Wi-Fi and still have connection to our server without the use of any wires. Also, another reason, I guess, is in rented accommodation, we might not be able to actually have cabling. So being able to use our Unraid server anywhere we can pick up a Wi-Fi signal, well, I think that's really awesome. Okay, so if we want to connect to a Wi-Fi network, obviously we need to have a Wi-Fi adapter. But this doesn't necessarily need to be built into the server. We can also use a USB adapter, plug that into the server, and have Wi-Fi that way. Now, obviously, I'm connected at the moment by an Ethernet cable, so that allows me to get to here and be able to turn the Wi-Fi on. Now, obviously, if this was a brand new server and I wasn't connected by Ethernet, in order to get to this part here, I'd need to boot with a monitor connected to the server, boot in GUI mode, and then with a keyboard and mouse attached, navigate through to this same section and set up the Wi-Fi from there. So, obviously, to use Wi-Fi, we need to change this to enabled. And here under regulatory region, we can leave this on automatic and Unraid will choose the correct region based on the settings in our server. But if for any reason that's not correct, we can click here and we can choose from the drop-down the correct region for our server. I'm going to leave mine on automatic and I'm going to click on to apply. Okay, so now it's actually scanning for various networks here. And here we can see currently it's not connected to anything, but here, Galactica, this is my Wi-Fi network. So on the right-hand side, if I click on the little icon here, I'm going to be able to connect to this Wi-Fi network. So here we put in our password, and just like our main NICs, we can choose here whether we use automatic DHCP or we can choose to use a static IP, being able to fill in the details below. I'm going to use automatic for DHCP, and with my password in, I'm going to click here, join this network. Okay, so now we can see I'm connected to Galactica, and if I click on the little info button here we can see the information about this network, and here's my IP address. So I'm going to copy that, I'm going to open up a new tab and paste that IP in, and we should go straight to the same server. Okay, so here I am here, connected by the Wi-Fi to the same Unraid server. So that's all working fine. But now let's go back to settings and then the Unraid network settings, because it's advised when we're using Wi-Fi that we don't also use LAN at the same time. We should either choose to use one or the other. But probably if you're using Wi-Fi, it's because you don't have a LAN connection anyway. But I do, so to make sure I'm only using the LAN, I'm going to have to pull out the network cable from this server. Now, I'm not actually going to do it whilst it's turned on, because if I do, I'm actually not going to be able to connect using the IP address that belongs to the Wi-Fi adapter. So what I need to do is I actually need to shut down the server, and then after the server's shut down, I can pull out the network cable, reboot it up, and I've got a pure Wi-Fi Unraid server. Okay, so it's back up, and I'm logged in. So going back to network settings here, we can see here there's no LAN, and I'm totally reliant on the server's Wi-Fi network. But when we are totally relying on Wi-Fi, there are some slight nuances with Wi-Fi that we don't have with LAN, and I'm going to explain and go through those now so you can see what they are. So before we dive into how Unraid changes things when we're on Wi-Fi, let's talk about the why. Now, the average Wi-Fi adapter, or Wi-Fi NIC, if you want to call it that, is different to a LAN NIC, and this is actually something that surprises a lot of people. With a Wi-Fi connection, your device only supports one MAC address. The MAC address is your device's basically its identity on the network, and with Wi-Fi, that identity is locked in. The router or access point uses it to create a secure individual connection. And in Wi-Fi, the MAC address is used for authentication, encryption, power saving, management frames, really everything. And if you try and sneak more MAC addresses onto the Wi-Fi adapter, like for VMs or containers pretending to be extra devices, well, the access point can get confused and even block the traffic entirely. So this is completely different from what we're used to with wired Ethernet connections. With Ethernet, we can create multiple virtual network interfaces. Each one has its own MAC address and therefore can have its own IP address. And the switch or router just forwards the traffic for all of that without really caring. But Wi-Fi isn't designed that way. It's a shared managed connection, and that's why a single Wi-Fi adapter just gives one MAC address and therefore one identity on the network. Okay, so now that we know that Wi-Fi can only give us one MAC address on the network, the big question really is, how does that actually affect the stuff that we're running on the server? Okay, so first, let's talk about how this affects Docker. So I'm going to go across here to the Docker settings, and I'm actually going to disable the Docker service. Okay, so here we are on the Docker settings page, and let's talk about how all of this is going to work if we're running the server on Wi-Fi. Now, this page has got a lot of important options, and some of them are going to behave very differently when we don't have a network cable plugged in. Now, the first thing you'll notice here is my BR0 here. It's got a pretty weird IP address starting with 169. Now, this is known as an API-PA address or automatic private IP addressing. And it's basically just a fallback address that the server gives itself when it's set to get an IP address automatically, but basically can't find a network to get one from. So, since I've got no cable connected here, my BR0 network is not going to be available. So, if this is offline, how do our containers get their own IP addresses and connect to the network? So this is where Unraid is actually doing something very clever. So what you're seeing here, custom Docker network type, when your server's connected via Wi-Fi, Unraid will automatically ignore what we've set here. Although mine says IPVLAN, if I'd changed it to MAC VLAN, it would make no difference. It would always use IPVLAN when we're using Wi-Fi. And the reason for this is that a Wi-Fi adapter, as we discussed earlier, only has a single MAC address. So IPVLAN is the perfect solution for this because what it does is allow all of our containers to share that single MAC address of the Wi-Fi card while still being able to have their own separate IP addresses. So also on this page when using Wi-Fi, it's recommended to set host access to custom networks to be disabled. So really, there's nothing you actually have to change other than that on the Docker Settings tab. So I'm going to re-enable the Docker service and click on to apply. Right, so let's go across to the Apps tab and actually install a new container. Now, I'm going to install Firefox here, and you can see here the network type for this one is set to bridge. Okay, so going across to the Docker tab here, I'm going to show you something at first glance that looks a bit weird. We can see here the IP address is that 1691, is an API-PA address here. But if I actually click onto it and go to Web UI, well, it's actually resolving and going through correctly. So that might seem a bit strange. Why is that actually happening? Well, if we go back to our settings here and go back to our network settings here, well, because our IP address segment is set to automatic, it's grabbing the API-PA address and it's being applied here. But the reason we can actually resolve it is something which is called ARP flux, which basically means when this IP address is called out on the network, even though this isn't the Wi-Fi address, the Unraid server kind of goes back going, hey, yeah, I've got that IP address, and it routes everything, all the port forwarding and everything works. But also, we could just type in the Wi-Fi IP address of the server, and the port number, and that will work too. So both addresses actually resolve. I just wanted to bring this up in case it looked a bit confusing when using a bridge network. But you'll probably find if you're watching this video in the future, the Unraid web UI has been altered so it doesn't display this quirk. Right, so let's move on. You can see here that some of my previous containers, they were actually set to use BR0. But if I try and start one of these now, obviously it's not going to work. And that's because BR0 is no longer a valid network when we're using Wi-Fi. And if I go here and edit this template, the Jellyfin template here, we can see here that the network type is actually set to none because BR0 doesn't actually work. So what I'd need to do is I'd need to change it here to custom WLAN 0. Now this actually uses a SHIM network and IPVLAN to allow us to specify a real IP on our network. And this Jellyfin container used to be on 10.10.20.31. So if I assign that and click on to apply and done, now we can see here it's running and it's telling us the LAN IP address correctly here. And if I open up the web UI, we can see here Jellyfin running correctly on its own IP address with all of my public domain copyright-free media here. Okay, so I'd do exactly the same to Steam Headless. I'd need to change this and change its network type again to the same and give it its own IP address as well. Okay, so other than that, with Docker, no other changes, everything will work fine on Wi-Fi. Just those few little quirks to look out for. Well, in fact, there's one other caveat that I think I should mention. Now, some routers or routers, however you pronounce it, they don't like IPVLAN. And one such one is a Fritzbox, which I think is quite common in Europe. They just can't handle well a MAC address having multiple IPs, whether that's Wi-Fi or from LAN. So if you have one of these devices and you're just using Wi-Fi, you may have difficulty assigning an individual IP address for a container due to the IPVLAN limitation of your device. Okay, so that's Docker and Wi-Fi. Now let's go on and go to Settings, then VM Manager, and let's talk about Wi-Fi and VMs. Because VMs are a different story to containers. Each VM wants to behave like its own physical computer. So that means with its own MAC address and its own identity on the network. Now that's totally fine when we're using a wired connection, but on Wi-Fi, that's just basically not allowed. Remember, Wi-Fi only supports one MAC address per client. That's baked into how the protocol works. So if we want to run multiple VMs and give each one a real IP like we normally would with BR0, well, that's just not going to work. It's a limitation of using just Wi-Fi on the server. But instead, what we can do is Unraid can use a virtual network called BR0. And you can see here at the moment, under default network source here, it's on BR0. So I'm going to change the default here to BR0. So all future VMs, the default, will use this type of network source. Now, if you've never heard of that before, it's basically what's called a NAT network. Now, imagine it's like a tiny private router built into Unraid. Your VMs still get internet access. They can ping out, browse the web, reach your Unraid shares, all the Docker containers. That all works fine from the VMs. But there is one catch. Devices on your LAN, like your laptop, they can't see into that actual VM. So you wouldn't be able to ping the IP address of the VM from the laptop, but from the VM you could actually ping the IP address of the laptop. So basically it's a one-way street unless you did some fancy extra setup on your network using fancy network rules that are way beyond the scope of this video. Okay, so now I've changed the default network source. I'm going to click on to apply here and go across to the VMs tab. Okay, so we can see there's a few VMs here on this server. And let's have a look at Pop! OS here. Now, if I edit the template and we scroll down to the network settings here, we can see here that the network settings, it's still able to be put on BR0. Now that's because BR0 still does actually exist. Because looking at network settings, well, of course, my ET80, my primary NIC, it still exists, but there's just no cable plugged in. So going back to the VMs tab here, if I was to start up Pop! OS, the VM will start absolutely fine. But if I try and reach out through the network, opening Firefox, for instance, well, I'm not going to be able to do anything. So let's shut this VM down. Now go back to the template here and change the network source from BR0 to VRBR0 here. Now you may be wondering if we actually changed the default network source in the VM settings, why it didn't change it for all of these. Well, it doesn't change what you've already got, but if I was to add, say, a new VM here, say we were going to add a Windows 10 one, for instance, if we scroll down now, we can see that it's already set to VRBR0. So the changes we made in the VM settings earlier, they apply to all of the VMs we create going forward. But any that were already created, we'd need to change the network type on them in order to be able to use them on the network. So if I start up Pop! OS now if I open up Firefox and say click on YouTube here, and we can see obviously everything's working fine. Now, the IP address of my Unraid server on the Wi-Fi is 10.10.20.106. So if I ping that, I get a reply back from the Unraid server because we can go that way down the street to the Unraid server to things on my main network. And if we go back to this server here, and let's make a new share, let's call it Pop! OS, and export this over the network. And if we go back to Pop! OS here, and let's open the file browser here, go to other locations. So in here, I'm going to type smb://10.10.20.106 /Pop! which is the network location of the share. I'm going to click connect and then connect again. And we can see we're connected to that share on the Unraid server. And if I make a new folder and we go back to the server here, well, we can see we can connect to it fine. But like I said earlier, the IP address that we're given, if we look here, we can see the IP address is not on my local LAN. It's 192.168.122.199. So I can't reach this from anything outside on my regular LAN. I'm not going to be able to reach this IP. But with that said, anything on my server, any other VM here, because they're going to be on the same network, if we use VRBR0 for them, they are going to be able to talk to each other. So for instance now, if I open a terminal window in the Unraid server and I ping that same IP address, well, the Unraid server, it can talk to it fine because obviously the VM is hosted on the Unraid server. Okay, so let's close this. Okay, so we've seen how VMs using Wi-Fi and VRBR0, which again is basically like a mini NAT router inside of Unraid, that works fine for most cases. You know, like browsing the web, shares, and yes, we could even use that same network type with GPU pass-through. We can do everything we can with a normal VM, except for that one thing of being able to access it from outside of our LAN. Now, there are some type of VMs where this might be a problem, and Home Assistant is one. That needs to talk to smart devices on the network, and we're going to need to be able to access Home Assistant from either a PC, a tablet, or our phones. So using VRBR0 for that is just not going to cut it. So just what can we do if we do need to have a static IP address on the main LAN? Well, Unraid does give us one trick, and it's a really clever one too. Now we can assign one static IP address to one VM at a time, and it will use a special virtual network interface here called SHIM WLAN 0. And to use it, we need to set a static IP address inside the VM and then tell Unraid to claim that IP address at the host level. Now, I think the easiest way to explain it is just to go through it and explain it at each different step. So, let's do it on Pop! OS first. So again, Pop! OS is still running on the VRBR0 network. So what I'm going to do is I'm going to come here and go to Settings, and I'm going to go to the Network Settings here, and under IPv4, I'm going to change it from automatic and I'm going to change it to manual. And for the IP address, I'm going to use 10.10.20.250. And the net mask, 255.255.255.0. And the gateway is going to be my router, which is 10.10.20.1. So with that done, I'm going to click on to apply, then shut the VM down. Okay, so now the VM's shut down, I need to open an Unraid terminal window. I need to bind the IP address that we just added to the VM onto that SHIM network, SHIM-WLAN 0. So what this command will do will tell Unraid that 10.10.20.250 should be bound to this SHIM network here. So let's hit enter, and that's done. So let's close the window, and now let's go back to Pop! OS here and edit its template, and going down to the network settings, I'm going to change the network source from VRBR0 to WLAN 0. And we can see here it says manual configurations required, and this here is giving us the information the same as what we've just done. So there's nothing more we need to do. So with that done, let's scroll down to the bottom of the page and click on to update. So let's start up the VM. And inside Pop! OS, let's test if we've got internet. And there we are, it's all working. Well, let's just play a video just to check it actually is. Okay, so it's all working. That's great. Okay, so let's minimize the window of this VM. And here I am on my pfSense router. So I'm going to go to diagnostics here and ping. And let's see if we can ping the VM from on our LAN from on the router. And there we are. 3 replies, no packets lost. The VM is totally accessible from anything on the LAN. Great. So the next thing is I'd really like to be able to access Home Assistant. So what I'm going to do is I'm going to shut down Pop! OS, and Home Assistant at the moment, it's still on BR0, as that's what I used to have it on. So let's just start it up, and here we can see that Home Assistant, its IP address is already static here, because that's the IP address I always have Home Assistant on, and that's 10.10.20.250. So now you can see why I chose that in Pop! OS, so I could do this demonstration. Anyway, let's close this and shut down Home Assistant. And with Home Assistant shut down, and because Pop! OS is also shut down, then with Home Assistant now, we can change its network adapter to be WLAN 0. Now, so long as we're not running both of these machines at once, then whatever VM we put on WLAN 0, so long as it's got a static IP address in the VM as well, it will have that IP address. So, what I'm going to do is I'm going to see if I can log in to the Home Assistant web UI. So I'm going to open another tab, and let's see if we can access the VM. Okay, so here we are, and if I click on to log in, we can see I'm here into my Home Assistant. So, all working fine. Now, if you wonder which IP address you've bound to SHIM WLAN 0, it's really easy to do. We just open up a terminal window and just run IP space ADDR space show space SHIM hyphen WLAN 0. And there we can see my IP address. Now, if we want to remove it, again, it's really easy. All we need to do is IP space ADDR space del space then the IP address. Then after the IP address, we need to add /32 space dev space shim hyphen WLAN 0. And that's removed the address. So, really easy. So that brings us to the end of the chapter on Wi-Fi. Now let's move on to the next chapter where we're staying on the VM tab and see what's new with VMs. Okay, so let's see what's new in 7.1 when it comes to VMs. First, let's have a look at a new CPU pinning feature. Now, if I go to this Windows 10 VM here and click onto Edit, and we can see this VM's using 8 virtual CPUs, which for me is 4 cores and 8 threads. Now, at the moment, they're all pinned here. But what I can do is I can deselect all of this, and then on the drop-down here, I can choose 8 virtual CPUs again. And what this will do is let Unraid choose which ones to use, and it can switch them whilst the VM's running. So this will use the Linux scheduler to do this and have the server use which cores it thinks is best at the time. Now, if I was running a gaming VM, I wouldn't use this personally with a gaming VM, because with a gaming VM using GPU pass-through, I'd want to have cores pinned for the lowest latency. So I'd pin them to cores that nothing else is using to give me the best performance. But for VMs where latency isn't such an issue, having Unraid be able to choose which cores to use and when is a really neat feature. Now this VM's not used for gaming at all, so I'm going to save the settings as they are. Okay, next. So now I'm going to click here onto Add VM. And if we scroll down to the bottom here, you'll notice something here saying User Templates. And I've got a Windows 98 VM template here. Now, yes, we were able to do that in Windows 7.0, but now there's something extra. And to show you that, I'm going to actually create another template. So here, I've got a template here for an old Razer laptop that I managed to break. And if I click on Edit here, and I scroll down to the bottom, there's various custom XML here, which makes the VM think it's a Razer laptop with its serial number and various other details about the machine. So, if I save this, and I'm going to call it Razer Windows 10, and now when I go back to Add VM here, what I can do is I can click onto this, and this little icon here will allow me to either save this to somewhere on my array, or if I click on Download here, it will download it onto my PC. So with that downloaded on my PC, I could send that across to a friend, and they would have all of the custom XML in a template ready for them to load onto their server. So let's simulate that. I'm going to delete this here. And now I'm going to imagine I've been sent this XML template. I'm going to click on to upload here, and there's the file there. So I'm going to upload that into Unraid, and now there's the actual template. So if I click onto it, I can install that exactly how it was, along with my custom XML. So a really neat feature, I think, for us to be able to export templates, back them up, and also be able to share them with others. Pretty cool, I think. Okay, so that's 2 new VM features already covered. So let's look at 2 more. Now these next 2 are limited to Linux VMs, and they're in to do with virtual graphics cards. So let's have a look at my Pop! OS VM here, and I'm going to click onto Edit. And if I scroll down here, we can see here I'm using a virtual GPU, of which I'm using a virtual QXL GPU. Now, you'll notice here on the right-hand side now is we can choose how many displays this virtual GPU supports, and also how much RAM that GPU has as well. So I'm actually going to choose here to have 2 displays and 64 gigs of memory. Now, this only works if you're using SPICE. It doesn't work with VNC. We need to be using the SPICE protocol in order to be able to see our virtual displays. But there's one other very important thing we need to do in order for this to work, is we do actually have to enable copy and paste as well. That's because it sets up a channel for SPICE to communicate, and this is a dependency for the multi-monitor QXL support to work as well. So we just need to make sure that we've got that enabled, otherwise it's not going to work. Let's scroll down, and I'm going to click on to update. So with those changes done, let's start up the Pop! OS VM, and I'm going to open it in the web SPICE client for the time being. Now, using the web console, even though this is the web SPICE client, we can't use multiple monitors. We actually have to use a desktop standalone SPICE client in order for this to work. So let's close the web SPICE viewer and go over to my laptop where I've got Virtio installed. Let's use that to look at the Pop! OS VM. Okay, so here we are with the desktop viewer in Pop! OS now. Now, desktop viewers will have an option to be able to enable the multi-monitor support. Normally in the top left-hand corner, you'll see a little icon like this, or somewhere where it says View. And we can see here that Display 1's ticked, but at the moment, Display 2's greyed out. And that's because we need to add some software into Pop! OS in order for this to work. So I'm going to open up a terminal window here, and I'm going to type sudo space apt space update space and sudo apt install SPICE -vd agent, because we're going to need the SPICE VD agent for this to work. Okay, so I'm going to hit enter. Okay, so that's done. Now going up here, Display 2 still disabled. That's because I need to reboot the VM first. Okay, so now if I click on the icon at the top, the view icon here, I can now select the second monitor. Okay, I'll just arrange this a moment. And I've had to make this one a bit smaller to fit it on the screen for recording. But here we can see multi-monitor support is working fine now. Just needs a few little things to get it going, but a pretty cool feature nevertheless. Okay, let's go back to the Unraid server now. Okay, now as I said earlier, that last feature doesn't actually work with Windows VMs. because what these QXL multi-monitor displays here, they give just one graphics card multiple heads. And Linux understands that, but Windows doesn't. Now, it is actually possible to have multi-monitor support on Windows, but not using this method here. But I'm sure this is something that's going to be built in very, very soon. But for those of you who are interested in how it would work, you would need to have 2 virtual graphics cards in the Windows machine, and also be using Spice, and also having the copy and paste for the Spice channel to be working enabled as well. So let's quickly have a look at it working and fire up this Windows 10 VM here. Now, unfortunately, there's no time to go in any more detail about setting this up than I have here, but keep an eye out to future versions of Unraid, and I'm sure this feature is going to be made very easy for us to set up from in the GUI. But now let's move on to my favourite type of virtual GPU, which has just been added. Again, for the moment, it only works with the Linux VMs, but in the future, it may well work with Windows. So again, let's go to my Pop! OS VM here, and I'm going to scroll down. Now, this type of virtual GPU will work really with any type of remote viewing protocol, whether it's VNC, Spice, or something like RDP. So I'm going to change the video driver type here from QXL to Virtio 3D. And what this does is use the power of a real GPU in your server. You can see here mine's an AMD GPU, and it currently works with Intel, AMD, but if you're using NVIDIA, it has to be with the open source driver, not the proprietary one. And so what this allows us to do is to actually use our real GPU with multiple different VMs. And all of these VMs can be running together. They just each use a little piece of the real GPU in their virtual GPU, giving that VM much better performance than it would have otherwise. Now, when using our GPU this way, obviously it doesn't actually output to a real monitor. We connect to the VM remotely. We could use Spice, VNC, or probably the best thing to use would be RDP. You get better performance remotely over that. I'm going to leave mine set here as Spice, and update the template and then test out the VM. So here I'm connected with the desktop Spice client, and when we're playing this ad here, we can see how smooth the video is. It's really, really good. But what I'm going to do is I'm going to open up a terminal window here, and I'm going to do the command glx gears space -info, and here we can see the 3D acceleration working here, and it's telling us here the frames per second that I'm getting. So I'm getting close to 4,000 frames per second, well, it's just gone over there. So pretty good. So let's try doing something else. Let's run a little game. So let's try this game on its story mode, and we can see here there's some nice 3D animation here. So it's working pretty well, I think. The virtual graphics card is certainly a lot better than we'd get from like QXL or something like that. So really cool, I think. And don't forget that this can actually be shared amongst multiple VMs at the same time. And you could also be using your GPU for something else, such as transcoding. So it can be shared between containers and the VMs. Okay, so that brings us to the end of the VMs chapter. So now let's move on to the chapter about importing foreign ZFS pools. Okay, so if you remember at the beginning of this video, I said you might wonder why I'm running a TrueNAS VM here. So this is all going to become clear now. So I'm running this TrueNAS VM here, which passes through an HBA card that's currently got 5 drives attached. Now, if we have a look inside of TrueNAS, I'm going to open its web UI. Now, I know some of you might be wondering how I actually did that. Come on, that's been around since 7. But just as a quick tip, if you want to do that, just edit the template and you can put in the web UI. If you're using a VM that, like Home Assistant or TrueNAS, exposes a web UI. Anyway, going back to TrueNAS here, if I go to storage here, we can see here I've got a RAID Z1 that's 4 disks wide, and it's also got an L2 which is an SSD that's 1 terabyte in size. And if we go to shares here, we can see I've just got one share here called docs. Okay, so the first thing I'm going to do is I'm going to actually export this pool. It's always best to export a ZFS pool before just moving it elsewhere. It's not essential, but it's just good practice. Now, on TrueNAS, make sure not to click destroy all data on this pool, obviously. So I'm just going to confirm the export here and disconnect this pool. Okay, so that's done. So now what I'm going to do is I'm going to shut down the VM, and I'm going to go to the main tab here at the same time, and we'll see the disks appear here in a moment. Here they are here, because now they're no longer passed through to that VM. So I'm going to stop the array. Now, obviously, you'd probably be adding these disks from a totally different system, so you'd have first shut down your Unraid server, then physically connected the drives to it, restarted it, and then with the array shut down, you'd be at the same point I am now. And you'd see all of the drives listed as unassigned devices, like I see mine here. So what I'm going to do is I'm going to click on Add Pool here, and I'm going to call this TrueNAS. And for slots, as there's 5 drives, I'm going to choose 5. Now, even though this pool has got an auxiliary VDEV and only 4 data disks, we just choose the total amount of disks in the pool and set it as that. So with that done, I'm going to click on to Add. And now all I'm going to do is just add all of the disks. And it doesn't matter the order you put them in. Unraid will just sort all of that out itself. So there's the 4 data drives and the SSD. And you'll notice here, the file system type is set to auto. Just leave it as that. And all we need to do is basically just start up the array. And there we have it. We've got the TrueNAS pool imported here. If I click on the file browser here, there's the share called docs. That's imported. And there's only one folder inside called untitled. There was nothing there. This was just for a demo. But if you had imported a Z pool full of data, it would all be there. You'd see it all here. But really cool. Very, very easy to import Z pools from other systems now. And we can see here, it's got the auxiliary VDEV connected here as well. So another really, really cool feature, I think. Okay, everyone, that was a very short chapter. And that is all of the major new features in Unraid 7.1. Now you can always read through all of the release notes to see absolutely everything. But this video covers all of the big guns brought forth in this release. And so that brings us to the end of another Uncast video. Now, if you're still listening to the video at this point and you haven't switched off yet, I'm going to ask you a favour. Please give this video a thumbs up, and if you're not a subscriber, please subscribe to the channel. Really trying to get this channel up to 10,000 subs, almost there, so with your help, in a couple of months I reckon we'll be there. Anyway, that's all I've got for you today, so I'll see you all another day in another Uncast video.